Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today we will start the new chapter, which is input design and prototyping. The objectives of this chapter are to talk about the format and media for computer inputs. We'll talk about three phases of computer input: data capture, data entry, and data input. We'll define several automatic data collection technologies. We have discussed in chapter 13 also that although keyboard and mouse is the most commonly used medium for input, but it has two main problems. First, it is time consuming, and secondly, there are chances of mistakes. So there are a lot of automatic data collection technologies. We'll talk about them briefly again in this chapter. We'll talk briefly about the psychological aspects, about the human factors of the computer inputs. Another thing we'll talk about in this chapter is the internal controls for computer inputs. The internal controls are used to make sure that all the input entered in the system is correct and complete. We'll talk about them. And finally, we'll talk about the GUI controls, all the common controls and guidelines of when to use what control. And finally, we'll see how to design an interface. Well, there are three steps in the input process. First of all, data capture is the identification and acquisition of new data. Well, many times nowadays, we enter the data directly into the system, but sometimes we use some source documents which can be used to collect the data, and then in the next phase the data is entered in the system. So source documents will be used to write the data in these forms. These are the forms which are filled by the users, mostly by handwriting, and then the data is entered in the system. It is translated into a computer readable format. Once the data is entered in the system, the next step is data processing. And we have discussed in chapter 13 also that there are three ways in which data can be processed. Batch processing is when we collect the data into groups, into batches, and we process the entire batch as a whole. For example, the employee attendance, let's say we keep collecting the attendance when they enter and when they leave the organization, and at the end of the month, we process the entire attendance to calculate salaries of the employees. It is batch input processing. In online processing, which is more common nowadays because we have mobile devices, we have cheap internet connectivity, so that data is entered and processed immediately. And remote batch is a combination of online and offline and batch processing. So we may collect the data online, we keep collecting it, but it is processed in the form of a batch whenever it is required. The second is input implementation method. There are many input implementation methods which are used to enter the data in the system. Keyboard and mouse, as we discussed before, that they are the most commonly used media, but they have two main problems. First is that they are time consuming, and the second is the chances of mistake. The error rate is high. So if we use keyboard, we may have more errors and it takes more time. So touch screen is also nowadays commonly used. All the people, they have handheld devices and touch is used, or the stylus is used, but stylus is also mostly used to enter the data like using a keyboard. Point of sale terminals, like all the checkout counters in the superstores, the ATM machine, the kiosk, all of these that represent point of sale terminals, which are like self-service terminals, which in fact they are more than simply input, they are complete systems, but we may consider them as input implementation method. because all the products, they are scanned, they are entered, and then the amount is deducted by cash or by entering the input in the form of card, credit card or debit card. Then sound and speech is another data capture method. Well, sound is used when we use telephone touch tones to get the data from the users. For example, many helpline systems, they have menus, so you call a helpline and then you will hear an automatic menu. Press 1 for this, 2 for this, 3 for this, and so on and so forth. And when you click a button, this touch tone is recorded as input for the processing, and so on and so forth. So many banks, they use this system for the online transaction management, for troubleshooting, for inquiry, for getting information. There are many applications of this system. Speech is when we speak to a system, like Apple Siri is one of the most common application that comes to our mind, in which we enter the data by speaking to it, and then the system will process it. There are many automatic data capture methods like optical mark recognition. We have discussed in chapter 13 also that these are specialized sheets which are used to record the input in the form of like filling circles. I'm sure all of you have used these sheets to answer the exam in preparatory year and in Sharia and many other courses as well. So you use a lead pencil to completely fill the circle, and when we collect all these student exam papers, we also have the key answer sheet. We put them in OMR scanner as a batch input. It will process all of them and automatically mark them and give us the output in the form of a result in Microsoft Excel format. So this is a commonly used input technique, which is used when we have large amount of inputs and we process them as a batch. Barcodes, or nowadays we also have QR codes. All of you are familiar with them. They are also used mostly in the industry, retail industry, or in many other applications as well. So instead of again user having to type the data by using keyboard, the camera will automatically, or a barcode scanner will automatically scan the code and enter it in the system. Optical character recognition is when you use the camera or a scanner to capture the typed or handwritten text in editable format. So the text is not scanned as image, but as a text that you can edit easily. It is called optical character recognition. There are many stable systems available for English language. I'm sure some are available for Arabic and other languages as well. Another automatic data entry method is magnetic ink. A magnetic ink reader is used to read this data. Like in many systems, we use a magnetic ink to record the data, and many times we also use additional input in the form of handwritten, like in a bank check. The customer will enter the additional input by signing the check and entering the amount to be cashed out, and so on and so forth. Or we used to have magnetic strips as well in the old cards. Nowadays, mostly the cards are replaced with smart cards, but in the old times, like your ID or driving license or other cards, debit or credit card, they used to have black magnetic strip at the back end. If you can recall, it is also used to store the data, and we use specialized magnetic ink reader to read this information. Then there is ER transmission, electromagnetic transmission, or most commonly they are called RFID, radio frequency identification system. Like in many superstores, you must have seen that we have checkout gates, walk-through gates. If you did not make a payment for any product and you just try to walk out of the store, an alarm or a buzzer will start. So basically we use RFID tags, radio frequency identification tags, and these RFID scanners, they will read this electromagnetic transmission from the RFID tags to track the product. So mostly they are used for tracking purpose, for security purpose, like in our university also, all the employees, they are given these RFID tags for parking and for the gates as well. So an RFID reader will read the information from this tag and do some processing. So it is used for tracking for security purposes. Smart cards, nowadays most of the cards, they are replaced with smart cards which have a chip on them. These old cards which had magnetic strips, they were susceptible to corruption. The data will become corrupt if a card is passed through a strong magnetic field. And they could also store less information. So nowadays we have mostly smart cards. These cards have a chip on it, and we can use a smart card reader to read the information from them. Finally, biometric, many human characteristics like our retina, like our thumbprint, our face, our hand geometry. There are many ways in which we can, mostly they are used for security purposes, we can identify the human from these unique human characteristics. So these are several of the automatic data capture methods which use specialized scanners to read the information, and we do not have to enter the information manually by keyboard. So in the next couple of slides, we have examples for all these methods, how the data is captured, entered, and processed. I will leave them for you as a reading assignment, ungraded of course, but I have explained all of them briefly. Coming to the guideline, the first guideline is capture only variable data, not the data that can be looked up. Well, we are looking to minimize the amount of input from the user because of obvious reasons. If we get more data from the users, it will be more time consuming and there are more chances of mistakes. So do not ask the user to enter unnecessary information. Like the first unnecessary information is the constant kind of data. Let's say, for example, the instructor is entering some grade information. So if the instructor enters marks and he is also required to enter grades, it will be a bad design. Like an instructor enters 95 marks, and if he is also asked to enter the grade, let's say he enters A or B grade, right? So there is a problem. This is a wrong design. So if the marks are entered, let's say 95, 80, or 75, whatever, we can always look up this information with the grading scheme. We all know that 95 and more means A plus grade. For 80 it is B, and so on and so forth. So we should not ask the user to enter this information. It will be a bad design. So this data that can be looked up, we have discussed in the database design chapter also that we can have lookup tables in which we can store this information, and the user should not be required to enter this information by himself. So any data that can be looked up, the user should not be required to enter that data. Do not capture data that can be calculated or stored in computer as program. So again, many times we can calculate some attributes from some other attributes. Like if an instructor has entered pre-final marks, let's say 40, and final marks, let's say 35. So the system can automatically add both of them to calculate the total marks, let's say 75. And if we ask the user also to enter this information, again it will be a poor design. We can always add up all these inputs to calculate this total marks. So any data that can be calculated from other pieces of input, the user should not be required to enter that data. Another design guideline is we can use code for appropriate attributes. We should try to minimize the amount of handwriting, or we can use some code for some attributes. Again, the idea is that the amount of time for the users to enter the data will be reduced. Like many times we use abbreviations like IS for information system, CS for computer science, KFU for King Faisal University. For male we use M, and for female we use S. So many times we use abbreviations to minimize, or codes to minimize the amount of time for the user to enter input. Next, we have some source document or form design guidelines. The source documents, they are used to record the business transactions. The forms which are used by the users to write their data in them, or even these things, they apply to the screen input design. Include instructions for completing the form. For every form, we should have clear instructions for the users. You can print them on the flip side, on the back side of the page, or on the top or on the bottom of the page, or in a screen input, we can provide them as pop-up or as a first introduction screen, but we should have some instructions for completing the form. Minimize the amount of handwriting. So many times we provide some options to the user, again because of the obvious reason, it will minimize the amount of time for the users to enter the input, and the chances of mistake will be reduced. So whenever possible, provide some options to the users to enter the input, and the amount of handwriting should be minimized. The data to be entered should be sequenced top to bottom and left to right. Again, it applies to both the source document, any paper forms, and also for the screen input, right? So the data should have a logical sequence from top to bottom and left to right. Talking about English language, if you're talking about Arabic language, it will be right to left. Whenever possible, use design based on known metaphors. I hope you know the metaphors. What are metaphors? Metaphors are some objects or some symbols, or in computer some icons, anything that relates to a real life thing. For example, we all know that for cut, we use this scissor mark, okay? Excuse me for my poor drawing skills. But for cut, the scissor is a known metaphor, right? Similarly, for pasting, we use this blue icon, or for saving, we use the icon of a disk. All of these, they are metaphors. A scissor represents a cutting action. So whenever possible, we should design the system by using metaphors. Again, it will make it easy for the users to understand the purpose of these buttons or inputs. So here is an example of a good flow in a form. You can see it has a very smooth flow. From Social Security, then we have salutation, Mr., Miss, Doctor, whatever. Then we have current date. We have first name, middle name, last name, address line 1, telephone, address line 2, and so on and so forth. But here you can see the entire sequence is messed up. So it is both logically and also the tab sequence. You know, I'm sure you know that there's a tab sequence also. Tab sequence. When the user enters the information here, he presses tab, he or she presses tab or enter, and he will move to this field. From here, he or she will move to this, and from here to this. But if from this field the user is going to this and coming back here, it is a very poor design. So we should always have a good flow, whether online screen or the paper form. The flow should be logical in the input design. This is an example of a metaphoric screen design. A ticket order form, it looks like a real life ticket. or if you want to get credit card information, if it looks like a credit card screen, it will be better for the users. Next, internal controls for the inputs. Well, we have a saying in the computer input design. We say that garbage in, garbage out. Garbage in, garbage out. Okay. So if we enter garbage in the system, we should only expect garbage from the system. So as a guideline, we should always try to make sure that there is no garbage in the system. There are two qualities of good input. One, the input should be complete. Whenever the user enters an information, try to make sure that the user has entered all the required input. And the second quality of good input is that it should be correct. Right? So there are many internal controls used to make sure that the input is complete and input is correct. Let's talk about both of them. So the number of inputs should be monitored to minimize lost transaction. So for completeness, we must monitor the number of inputs that the user is entering. We must make sure that the user has entered all the inputs. For batch processing, so if we are using a batch input processing method, we have many inputs, so some of the inputs might be lost. So what we can use many methods, like we can use batch control slips. What is it? It includes the data like batch number of documents, and some kind of control total, like total number of lines on the batch document. So when the data is entered, we will compare the entered number of record items with the batch control slip to make sure that all the data is entered in the system. We also use one-for-one check against post-processing details report. Okay, so we can also use one-for-one check to make sure that each and every item has been entered correctly in the system. For online system, log each transaction as it occurs to a separate audit file. I hope you remember that we had discussed in the database chapter also the role of audit files. Whenever a transaction is made, it is stored in an audit file to be able to track all the inputs, right? And if there is anything missing, we can always track it out. So these are internal controls to make sure that the inputs are complete, they are completely given. The second type of internal controls are to make sure that the data entered is correct. Okay. So there are many types of validation checks which are used to make sure that the data entered is correct. The first is existence check. So existence check will ensure that the required input has been entered. The user did not miss it. Like in web forms, many times you will have seen that there is an asterisk with a field. If you do not enter information in this field, you will not be allowed to move further. So you must enter the information for this field, and we'll make sure that the inputs are complete. The second is data type check. We have discussed in the database design as well that the data type check will ensure that the type of data entered is of correct type, right? The type of data entered is correct. For example, alphabetic data should not be allowed in a numeric field. Like if there's a GPA field, the user should not be able to enter ABC, right? Next is domain check. Again, we have discussed in the database design chapter also that sometimes we have a list of values. Okay. For example, for gender, the domain is male and female, or sometimes we have a range of values. Like for GPA, the range of values is between 0 and 5.0. So whether it is a list or a range of values, the domain check will ensure that the value is within this limited set or within this range that is required for this attribute. Combination checks, all these first three checks, they are for single fields. They are applicable for single field. Combination check is applied for two fields. Sometimes there is a combination between two fields. For example, let's say if the user selects college as CCSIT, college, then for department, the user has only 4 options. The user should be able to enter either IS, CS, CE, or CN. These are the only allowed for values based on this college. If the user selects another college, then its departments should be available for selection in the next phase, right? So many times you will have seen that a drop-down list, when you select an option from first list, it will populate the second list based on the value you have selected in the first list, right? Or here another example, if vehicle make is Toyota, then vehicle model must be one of values like Camry, Corolla, Fortuner, Land Cruiser, Valona, etc. Tahoe is not an option if the user has selected Toyota as the make of the vehicle, right? Next is self-checking digits. Sometimes you see a single number for certain field, but actually there are two numbers. And a part of the number is calculated from the main number and it is appended in the beginning or at the end of the actual value. Like I'm sure you have also discussed checksums in the network course, right? So whenever a packet is sent, a checksum is also added with the package, and then the receiver can make sure that the packet is completely delivered. The same idea here. Well, I'm sorry if you could not hear me or if you could not see the slides. Let's hope everything is fine. So, for text box is used when we cannot predict the values. Okay, when we have unlimited values, then we use text box. If we have a large amount of text to be typed, then we may use multi-line text box. Radio buttons, they are used when we have mutually exclusive values. It means any one of these values will be available, will be applicable for a particular record or input. Right? The checkboxes, they are used when the options are like yes, no, where multiple values may be selected. Well, these are the obvious controls. Let's move to the more trickier controls. This is a list box. List box is also like radio buttons. Okay, it may be used as a checkbox as well, but mostly it is like a radio button. The difference is when we have large number of values which cannot be fit as a radio button, we use a list box. So if let's say we have 3, 4, 5 values only, which can be put on a screen, we use radio button. But if we have large number of values, then we use a list box to put these values into it. So the trade-off is that the radio buttons, they take more space, but the user can select a value with one click. For the list box, the user will have to open the list box, then maybe scroll down and select a value. So it is more time consuming. It takes less space. It may take less space for a large number of values, but it may be more time consuming. Similarly, drop-down list. Drop-down takes even less space than the list box, but again, it is even more time consuming. So if we can put all the values in the radio button, we will use this. If we cannot put them, but we can choose at least some values on an input screen, we will use list box. If the screen space is too tight, then we will use the drop-down list. Next, combo box. Combo box is a combination of drop-down and text box. So it is 2 in 1. Okay. If we add both of them, we get a combo box. As you can see here, editable. So either the user can select a value from the available values, or the user can add a value like in a text box. So combo box is a combination of drop-down and text box. Finally, spin box. So user can use up and down arrows to increase or decrease the value, or they can enter directly like a text box. So these are this explanation of all the controls that I just gave you. Then there are certain advanced controls like drop-down calendar. This is a drop-down calendar. The user clicks it and he or she will see a calendar from which any date can be easily selected. Similarly, slider edit control can be used instead of spin box, in which you can slide between the values. Mask edit control, in which we can put a specific format. Like here, we have put a format for the telephone number. Okay. Check list box. As we said before, that list box can be, mostly it is a radio button, but it can be implemented as a list box, as a checkbox as well. So a checklist box is a list box of a list of checkboxes, right? Then here, ellipsis. You might have observed this ellipsis in some user interfaces, like with the browse button or with save as button, or with many buttons you will have seen this. So these 3 dots, they are used many times in the graphical user interfaces to show that there is some additional input required for this field, right? Alternate numeric spinner, so like a spinner, like a spin box, that we can have plus and minus, and there is check tree box, in which the check boxes are organized in the form of a tree, and there is also hyperlink control. So there are many advanced controls available in Windows interface. Similarly, for web-based systems, there are many scripts available, online scripts that you can download, and you can use many interesting controls in your systems, web-based systems. Talking about the tools, there are many automated tools for input design and prototyping. The old tools were record layout chart or display layout chart, and as we have seen in the output design process. But nowadays, mostly we use any kind of what we call visual. What you see is what you get. Visual kind of tools like Microsoft Access, Chaos Tools, Visual Basic, Excel, Visio, Azure. There are so many tools available which can be used for prototyping purposes. The input design process is simple. We identify system inputs and review their logical requirements. We select appropriate GUI controls for each field that we have identified in the logical requirement in the form of logical data structure. We'll talk about it later. So for each field, we identify most appropriate GUI controls. This is the most important step, right? So for every field, I have seen many students using text box for everything. Text box. This is the worst possible design, right? So do not use text box for every field. Try to minimize the amount of typing for the user. Always try to give some options, whether through radio button, checkbox, list box, drop down, combo box. There are so many controls we discussed, right? So you can use text box for everything, but it will be a very, very bad design. We should always select the most appropriate GUI control for every field. We'll talk about it, inshallah, in a case study, how to select it. Validate and test the input using some combination of layout tools and prototyping tools. So we use these tools to design the inputs, to validate them from the users, and to test them. And finally, if any source documents are to be designed, we also design them. This is an example of a logical data structure, as we have seen in the previous chapter. The logical data structures are a good tool to identify and arrange the fields that will be required for an input screen. A few examples at the end. Let's come to a case study. We will discuss a small case study to see the input design process, and then inshallah you will have a chance to apply this technique for your course project input design, inshallah. This is a process for input design. So we start from physical DFT. We identify all inputs of the system and review logical requirements, right? So if we have used physics data flow diagram, then all the data flows from external agent to the processes are your system inputs, right? Similarly, if we have used object-oriented technique, then you can use those diagrams to identify the inputs from the actors to the different processes or the objects. Right? For each input in your system, develop a logical data structure to identify the attributes required for that input. Just like we saw now, a logical data structure, and even we saw in the output design process, a logical data structure will help us in identifying and organizing the fields which will be required for each input screen. For each input screen, develop the input description. We will see shortly how we can develop the input description and how it helps us in selecting the most appropriate GUI control. This is the most important thing in the input design. We'll see inshallah in the example. Design input screen by using any tools like we have discussed before. We validate the inputs, we revise if necessary. If we get some feedback from the users, we revise it and come up with a final design of input. Let's take a case study, the input design for entering recruiting requirements. It is the same input related to the output we discussed in the last chapter. So when the recruiting requirements are entered by a dean or head of department, and then they are given to the recruiting committee. So the dean or HOD, they enter the recruiting requirements in the recruitment information system. The case study that we are well familiar with, we have started it in SAD2 course. This is a logical data structure for the screen, and I hope you can see that it is very similar to the output design except a few things. Like first of all, in output, we also had a date field, but now we do not have in the screen. Why? Because date can be taken from the system. When the user is entering the input, we can always get the date from the system, so there is no need to get date from the user, right? Similarly, if you recall, in the output, we had total number of vacancies, right? Total number of vacancies. Total number of vacancies. Again, this is not required in the input because we can calculate from the number of vacancies. The user has entered number of vacancies for different titles. We can add all of them together to calculate total number of vacancies. So we do not need to waste the user's time for entering total number of vacancies, right? So otherwise, you see that this the number of fields, they are pretty much the same as they were in the output design. These are some of the checks we have discussed in the previous slide, and just for your revision purpose, for every field we need to identify which check should be applied for every field. So existence check, data type check, domain check, combination check, checking digit, and format check. So maybe for some field only this check is enough, but for another field maybe these 4 checks are required. For another maybe this and this are required. So for every field we will identify the most appropriate validation checks that will be required for that field. Let's go through the process. So for this input screen, recruiting, entering recruiting requirements, the first field is title or rank. The first thing is data type. So the type of this field is a string. So the title can be lecturer, teaching assistant, assistant professor, associate professor, or a full professor. So the data type is string. Type of number of values. Well, here this is important. It will help you in the design process. How? For some fields there are fixed number of values, right? Set of values. For example, for gender, we only have 2 values, male and female. So for this field, for this attribute, number of values, I will say 2. There are 2 values, and what are the possible values, male and female, right? So for some fields, the size will be important. Like for name, let's say what is the maximum characters that the user should be allowed to enter the name. So let's say if I just say 10 is the size of name field, it will not be enough. For the name, let's say I'll pick 20 or 30 or 40 characters because the name can be pretty long. Muhammad, Abdurrahman, Abdul Latif, Al-Muslim, let's say. So it's a very long name, right? So for some fields it will be size, and for some fields it will be number of values. As I told you, for gender, the number of values is important. We have 2 values. For the name, let's say the size is important, right? So for every field we have to see whether the size is applicable or number of values. If there are fixed number of values, we will put the number of those values over here. For example, for title or rank, we have fixed values, 5. What are those values? Teaching assistant, 1, lecturer, 2, assistant professor, 3, associate professor, 4, and full professor, 5. So these are 5 values, right? 5 values. So here I have put 5, and here I have put those 5 values. So if it was a gender, I'll put 2 here, and here I'll put male and female. Got it? Next, validation check. So I have put existence check. It means for every input, the title must be given, and domain check to make sure that the value is not outside this set. Domain check will ensure that the value is one of these values, and existence check will ensure that the title must be given. So for every field you have to think what are the most relevant validation checks. What is the most appropriate user control? I have picked radio button. You may consider list box as well. You may consider drop down list. It will vary from designer to designer. I have picked radio button. It is one of the valid options for this, right? Default value is the most common value. Like in our college, assistant professor is the most common. You know that most of the people are assistant professors, and these are the this is the most, this is the highest number of vacancies in this rank. Right? Next, number of vacancies. So for every kind, the head of department will also need to enter the number of vacancies. Like if the HOD needs teaching assistant, how many of them we need? Assistant professor, how many of them? Full professors, how many of them we need? Right? So the data type is integer. Now here, whether size or number, what is important? So it is size. We do not have number of values. You could have said like 99 values, but I have taken size, the 2 characters values, that it should be more than 0. Any value between 1 and 99 is valid. I have taken existence check, data type check, and domain check. Existence to make sure that the user always enters the value, data type to make sure that it is integer, and domain to make sure that the value is greater than 0. The user should not be allowed to type -1, right? So we cannot hire -1 people. Okay. Next, most appropriate GUI control. For this, I have selected spin box. You may have selected slider control or a text box, but in my opinion, spin box is a good option. Default value is 1. Minimum qualification. For every vacancy, there is minimum qualification. The data type is string. We have size for this, 50 characters. We do not have any fixed number of values. I have taken size as 50 characters. What are the possible values? We do not have any possible values for this. The validation check is only existence. The other checks, in my opinion, they are not applicable for this. The most appropriate GUI control is a text box, and there is no default for this. Similarly, for the minimum experience, it is integer. The size of 2 characters. You should have non-negative value, or you could have written greater than 0, okay? Or, sorry, not greater than 0, it is 0 and more. So for some time we may have the 0 experience requirement, like teaching assistant, no experience is required, so 0 is also okay, but it should not be like -1 or -2. Validation check, data type to ensure it is integer, existence to ensure it is given, and domain to ensure that the negative value is not given. As selected spin box, default value is 0. Similarly for job description, these are the values for all the attributes. Next was expected salary, data type is float. Here again, the size 8 characters, possible value is, I have taken at least 10,000, but again it depends on the requirements. What is the minimum salary for the individuals? Validation check, data type to ensure it is a float value, existence to ensure it is given, domain to ensure it is more than 10,000, and finally I have also given format check to ensure that the value is given in an amount format. When the GUI control I have taken text box, you could have selected spin box or slider control as well. And default is 10,000 reals. Opening date is a date data type. We have 10 characters. While possible values or domain for this is greater than or equal to today. So the opening date should not be in the past, right? The validation data type to ensure it is of date type, existence to make sure it is given, and domain to make sure it is not given in the past. Most appropriate GUI control is calendar. Default value is today. So the user, when he or she enters a new vacancy, today will be taken as the date. Similarly, closing date is date, size is same. And now the domain is, it should be greater than the opening date. So closing date should not be less than or equal to the opening date. It must be greater than opening date. So now here, instead of data type existence, we also have combination check. There's a combination between the closing date and opening date. Right? Calendar control is the most appropriate, and default value is opening date plus 30. It means the vacancy will remain open for at least 1 month. But again, it must be based on the user requirements. Right? I hope you understand the process. So now at the end of this practice, we have selected the most appropriate GUI controls for all the fields. In the last step, we need to develop a prototype by organizing them in a nice, neat format. So here, this is how I have designed it. So enter recruiting requirements is the input. This is the title or rank, the possible 5 values, the number of vacancies, I will inbox, minimum qualification, minimum years of experience, text boxes, expected salary text box, opening date, calendar control, closing date, calendar control, and job description is multi-line text box. And in fact, input design is more than this. This is what we did explicitly, and we can also be more creative to give a good user experience to the user. So we also need to add buttons. Like here, what I have done, I have merged this input with the output that we have designed before. So whenever a user enters any vacancy and clicks Add Vacancy, it will create one record here. And you can see the user can edit or delete this record as well. Then user enters another vacancy and another record will be added here. User enters another vacancy and it will be added here. And at the end, user can enter notes only once. If you remember, all these fields, they were between 1 to n blocks. Let me take you back to this slide. In my data structure, logical data structure, these fields, they were in 1 to n block, right? And this field, it is only given once, right? So many values can be given for this, but there are only one nodes that can be given. So if you go to the input prototype, the screen prototype I have developed, you can see that here the user can enter many records, but at the end user gives the nodes only one time, and then he can save and exit or exit without saving if the user has changed.